The second one, heat emission by conduction. As you see, there are two formulas. How to understand which one to use? Easily. If air movement speed less than 0.6, you have to use first formula. If air movement speed more than 0.6, you have to use the second one. As our air movement speed 0.8 according to the home task number 4, we will use second formula. What do we need for our task? We need body temperature 35 according to the home task, T2 air temperature 12, then we have two coefficients, then air movement speed, in our task it's 0.8, and body surface area. We using the same table, but in this case we need 100% because in conduction we have all 100% of the body. 70 kilogram of our body weight of our person, and here's the body surface area. Our calculation: 7.2, then 35 minus 12, 0.27 square root from 0.8 and multiply 1.922. I want to pay your attention for the mathematical rules of calculation. First we're doing calculation in the brackets, and only then we're doing this multiplication one by one. And the final result, that heat emission by conduction, 369.2 kilocalories per hour. Next, heat emission by evaporation. This calculation will consist of your steps. We have a formula, amount of the moisture evaporated from the skin surface. For this formula, we need F absolute. Here is this formula. We need to calculate using this formula F absolute, where we have F relative, relative humidity under current air temperature. We have in the task 85%. And F maximum, maximum humidity under air temperature. Where to find this value? In topic number 6, we had this table, maximum pressure of the air vapors of the premises. It's table number 3 in the topic number 6 in the book. And we know that air temperature 12 degrees, and here's our F maximum for our calculation. When we will put in the formula F absolute, all our value 85, 10.518 and divide by 100, we will get that F absolute 8.9 hydroargon millimeters. Next, we will put everything to this formula. Coefficient, F maximum, maximum humidity under skin temperature. Again, we back to the topic number 6. To this table, and our body skin temperature 35 degrees, and here's our value 42.175. Then air movement speed 0.8 given in the task, and body surface area we taken as the same as for previous calculation, 100% according to the table, 1.922 as for previous formula. So 15, 42.175 minus 8.9, multiply 0.5 plus square root 0.8 and multiply 1.922, and 1333.45 kilocalories in hour. It's milliliters in hour. Milliliters in hour. It's amount of the moisture which evaporated from the body surface. And to convert it to kilocalories, we need to multiply by coefficient 0.6. 0.6, and it will be 807. Next, what do we have to do? We need to calculate Q total. We need to add heat emission by irradiation, by conduction, and evaporation. and to find the total value. So total heat emission, radiation, conduction, evaporation, 1342 kilocalories in hour. Now we need the heat production. Calculation of heat production, it's complex calculation. It should take into account the body weight and production of the kilocalories per kilogram in hour, and also physical activity coefficient, etc. That's why we will take that approximately using easy work this person producing 500 kilocalories in hour. So we have heat production 500 kilocalories in hour and heat emission 1342 kilocalories in hour. What we have? Heat emission more than heat production. So if heat emission more than heat production, then microclimate, discomfortable, of course, if we don't have equivalence here, discomfortable, and it's cold. We're losing more than we're producing. Discomfortable,